Hi everyone, lesson 4.4 is once again looking at Microsoft Excel. Now similarly to units 2 and 3, I'm going to walk you through one type of one of each style question, okay, finding present value and future value, payments, and interest rates. But in this case, we're going to look at annuities due and how you make a small manipulation in Excel to allow you to calculate for an annuity due instead of a simple annuity. Okay, so remember, annuities due are when payments are made at the beginning of the payment period, not the end. Okay, and you're going to see it's kind of one tweak here that we're going to make. So the way I'm going to structure this, you'll see my spreadsheet looks similar to when we did the videos in Unit 2 and Unit 3. Where I have questions laid out and I have each of my inputs or outputs depending on if I'm using a formula here. My difference here is I'm going to walk you through the solution all the way through, doing all of the formulas for the first question. And then if you scroll a little bit down, you'll see I have formulas in here already. So if you want more of a refresher, those formulas we've been doing, this will be our third video doing them now. You can go back to our previous videos or just watch this first one. So I'm hoping that this first example will give you enough of a refresh to help you through the rest of them. So I do recommend that you have an Excel spreadsheet open. Okay, you can pause it and add these inputs if you choose to, kind of as you go along, just to kind of get a feel for what I'm doing here. So let's start with our first question. Find the present value of an annuity with payments of $3,000 made at the beginning of 5 consecutive years if interest is 6% per annum compounded quarterly. What we notice here, payments are made at the beginning of each year, which is annually. So that means it's an annuity due. But interest is compounded quarterly. So they have a different, so interest and payment periods are different. Okay. So that means that it's a general annuity due. You'll see examples of both types in here because I want you to start getting familiar with, understanding these differences so you can pick them out and figure out which formulas to use. So we're going to start here by finding the payment. Okay, so our payment here is $3,000. Remember, we put it as negative because it's an outflow of cash. Our nominal interest rate is 6%, so we can either do equals 6 divided by 100 and let Excel do the calculation for you. Okay, it comes out as 0.06. Or you could type in 0.06. Okay, or you can go up here, select percentage, okay, and then just simply type in 6. What I caution you with percent, and I see this a lot with students, is if your cell is set to percentage, you have to put 6% in here. If you go back here now and you type in 0.06, it thinks, if I click back to this cell, that you put in 0.06%, not 6%, okay, which is a much smaller number. I have seen this mistake happen with students. So it's totally fine to use that power in Excel. And it does save you from having to convert. You can use the 6 that's right here. But it is easier for you to make a mistake that way. So I'm going to just leave it. I'm going to go back up here and just put it as a number. And I'm going to just type in 0.06. But any of those 3 methods are perfectly fine. Our number of payment periods per year, okay, remember it's paid annually, which means 1. Our number of interest periods per year, it's compounded quarterly, which means 4 interest periods per year. Our ratio, C, if you remember, is equal to our number of interest periods per year divided by our number of payment periods per year. Okay, so that also comes out to 4 because it's 4 divided by 1. Our periodic rate of interest is equal to our nominal rate of interest divided by our number of interest compounding periods per year. Comes out to 0.015. Our equivalent rate of interest P, remember, that's equal to 1 plus our periodic rate of interest, keeping that in brackets, raised to the exponent of our ratio C, so I select C, and then minus 1. You could have added additional brackets here just to be safe. I didn't, just because I know it's going to follow order of operations. So I'll press enter, and I come out with our equivalent rate of interest right here. You notice it's slightly higher than the nominal rate of interest. That makes sense because we're only paying once per year, okay? But our interest is being compounded 4 times. Our length of investment is 5 years. So our number of payment periods is simply our length of our investment times our number of payment periods per year, which comes out to 5. So now, if we want to find present value, it's the same formula we've used in the past, but with one small change. So equals the present value, PV, of, starting with our first item, our rate. Remember, it's our equivalent rate of interest. Then we select our number of periods, which is N. Our payment, which is $3,000. Then it asks if we know the future value. Remember, in square brackets, you don't have to put that in. If you don't know it, you put 0. And then we come to the end. This is where that difference is. We always in the past placed 0 because it was always done at the end of the period. But in an annuity due, it's the beginning. So what it allows you to do is you can either, just select that one, okay? Or you could use your up and down arrows to go to it. Or you notice there's a 1 here. So you could also just type in the number 1, okay? End bracket and press enter. So you see here that our present value comes out to $13,362.94. Now I want to go back and compare. So remember this number, $13,362.94. I'll do it right beside it. Okay? So I'm going to do one right beside it, picking our rate of interest, our number of periods, our payment. We don't know the future value. And in this case, I'm going to do payments at the end of the period. And what you will see is a much smaller number. Okay, so you see there's almost $1,000 difference. That's because this one is including that extra period where you're earning interest. Okay, that extra period where you're earning that 6.14% interest that's listed here. Okay, that's the big difference with an annuity due. All right. So let's look at another example. Find the future value of quarterly payments of $50 made at the beginning of each quarter for 10 years if interest is 8% per annum compounded quarterly. So what we see here, we have quarterly payments and quarterly interest, meaning it is a simple annuity, but payments are at the beginning of each quarter, meaning it's a simple annuity due. Okay, so with that in mind, I do not have our equivalent rate of interest here because we don't need it. So our payment is $50. So negative 50, remember it's an outflow of money. Our nominal interest rate is 8%. So I can convert to a decimal as 0.08. Our number of compounding periods per year, okay, it's quarterly, so it's 4. You'll see that my periodic rate of interest is calculated automatically, 0.08 divided by 4. Our length of investment is 10 years, so our number of payment periods is also calculated automatically, 10 years times 4 payments a year, so that comes out to 40. So now we just have our future value, equals FV. We start with our rate of interest, which is our periodic rate of interest here, because we are not a general annuity, we're a simple annuity. Our number of periods, N, is the same, it's 40. Our payment, $50. Present value, we don't know, so we just type in 0. Our type, remember, beginning of the period, so we type in 1 here. Okay? And it comes out to a future value of $3,080.50. Okay? So our third question, now we're going to move to finding payment. And we'll do, two examples, finding payment with future value and then finding payment with present value. This is another area that I see students make a mistake on, is determining if a number provided in the question is a future value or a present value. So I'm going to try and walk you through that as well as we're doing this example. So what deposit made at the beginning of each quarter will accumulate to $10,000 in 4 years at 4% per annum interest compounded semi-annually? So we see our compounding period is semi-annually, but our deposits are at the beginning of each quarter. So they're different, meaning it's a general annuity. And since payments are at the beginning instead of the end, it's a general annuity due. Now when we look at this number here, we're looking for an amount of money to accumulate to $10,000, meaning sometime in the future it will equal $10,000. That's how you know that your that you have a future value here of $10,000 and not a present value. Okay, so I'll type in $10,000. Our nominal rate of interest is 4%. Converting that to a decimal is 0.04. Our number of payment periods per year, we're paying quarterly, meaning 4 payments a year. Our interest, though, is compounded semi-annually. That puts us at 2. So that means our ratio, number of interest divided by number of payment periods, is 2 divided by 4, which is 0.5. And our periodic rate of interest is 0.04, our nominal rate of interest, divided by our number of interest periods per year, which is 2, comes out to 0.02. That gives us a very small periodic rate of interest, or equivalent rate of interest, sorry. Okay, you'll see that here. Our length of investment is 4 years, so I'll type in 4. That means we have 16 payment periods here. So now we can determine our payment. So equals our payment. So we have our interest rate. Remember, you select your equivalent rate of interest here because it's a general annuity due. Our number of periods, which is 16. Our present value, which we don't know, so we type in 0. Our future value, we do know. We select $10,000. Then again, it comes down to type, which we have to press 1 for beginning of the period for an annuity due. And you'll see our payment comes out to $573.95. Now you can choose to make that a positive number. Remember, it's an outflow of cash. You could choose to have it show as a positive number just for the purposes of our spreadsheet by changing the $10,000 to be negative, and then it'll come out to positive. It's up to you. It is technically an outflow of cash, all right? So our payment would be our payment, leaving our bank account to our savings account. Okay. So next, we're going to look at finding payment, but this time it's the present value. Okay, and you'll see a lot of my differences are, in this question, it's accumulating to a certain value. Present value normally means you purchased something or you took out a loan. Okay, so if you buy a house for a certain amount of money, that's present value. If you have student loans that you're paying off, that value is your present value. Okay, a lot of times items like that, it's present value, not future value, because that's the value of whatever you have, whatever your student loans are, whatever your house is, the day you purchased it, okay, or the day you start paying your student loans in that case. All right? So for present value, what payment should be made semi-annually at the beginning of each period to pay off a loan of $8,000 in 10 years if interest is 10% compounded semi-annually? Okay, so we have a loan of $8,000, meaning you're given $8,000 today. That's the present value of that cash, okay? Not future value as it accumulates interest when you're paying it off. Okay, so you know that that has to be the present value. Now we look here, our payment is made semi-annually. Our interest is also semi-annual. Also, our payment is the beginning of each period. So, since our interest and payment periods are the same, it's a simple annuity. And since payments are at the beginning of each period, it's a simple annuity due. Okay, so you'll see here I do not have the extra items for the ratio and the equivalent rate of interest that I did up here. You can keep those in there, and you'll see that the number for equivalent rate of interest will just be the same as the periodic rate of interest. It's up to you if you want to do that, but you do not have to. Just a couple extra steps. Okay, so our present value of our loan is $8,000. Our nominal rate of interest is 10%, converting that to a decimal, 0.10. Our number of compounding periods per year, it's semi-annually, which is 2. Gives us a periodic rate of interest here of 0.05. Our length of investment in years, it says 10 years in the question, so we'll type in 10. That means we have 20 payment periods total. Okay, 10 years times 2 payments a year. So now we get to our payment equals PMT. Once again, we start with our rate, which is our periodic rate of interest here. Our number of periods, which is 20. Our present value, which we know in this case is $8,000. Our future value we don't know, so we type in 0. And we get to the end. Remember, it's at the beginning of the period, so you can click here if you want, double click, or you could just type in 1 like I've been doing so far. End bracket and press enter. And you'll see once again it comes out as a negative number because it's an outflow of cash, right? You're paying off your loan. If you switch this to a negative number, your payment would come out to a positive value. Okay? All right, a couple of examples left. We're halfway through. Now we're going to find N, which is the number of payment periods, once again with present value and with future value. So how many quarterly payments of $600 at the beginning of the quarter are required to repay a loan of $5,400 at 6% per annum interest compounded annually? Okay, so we have quarterly payments and interest is annual. So we have a general annuity. Payments are at the beginning of each quarter, so that means it's a general annuity due. Okay, so we're repaying a loan. Anytime you see loan, it has to be present value, okay? Because you're repaying that loan back. You got that money today and you're repaying it, all right? So our loan is $5,400. That's our present value. Our payments are $600. Remember, negative $600 because it's an outflow of cash. Our nominal rate of interest is 6%, which is 0.06. Our number of payment periods per year, okay, we're paying quarterly, which means 4. Interest is compounded annually, meaning 1 period per year. So we come out with a periodic rate of interest of 0.06, because it's just 0.06 divided by 1. Our ratio is 1/4, or 0.25, and it gives us this for our equivalent rate of interest. So now we need to find the number of payment periods. Remember, equals, we're looking for NPER. Now here we need our interest rate, which is our equivalent rate of interest, our payments, $600, our present value we know in this case, $5,400, our future value we don't know, so we type in 0, and once again, our payments are at the beginning of the period, so we're going to select 1 here. Okay, so that comes out to 9.57 payment periods. As a comparison, we'll look at this if it was a general annuity, an ordinary general annuity, not a general annuity due. So if I do that, okay, I would type in my rate here, my payment, my present value, future value we don't know, and I'm going to put end of the period. Okay, and you see it takes a little bit longer to pay that back. And that makes sense, okay? Because you're paying at the beginning of each period. So every time you make a payment, you no longer have to pay interest on that. So every time you pay $600, you're paying interest on $600 less of your loan, okay? So if it's at the beginning of the period, you're not accruing interest during that entire period after it, okay? So if you're paying monthly, and you pay at the start of the month, you're not accruing interest for those extra 30 days in the month, okay, or 31 days, depending on the month. Okay, so it does make a difference when it's annuity due versus an ordinary annuity. Okay. All right, next question. How long will it take for $200 deposited at the beginning of each quarter to amount to $5,726.70 if interest is 6% compounded quarterly? So again, quarterly payments, but our interest is also quarterly. And our money is deposited at the beginning of each quarter. That makes it a simple annuity due because the interest and payment period frequencies are the same and our payments are at the beginning. So it's trying, you're putting money in to get to a value of this. That means that's the future value. That's how much your bank account's going to have. Okay. In this case, however number of years. We don't know because we're trying to find that. So we know our future value, $5,726.70. Our payment is $200. Remember, it's $200 out of our checking account into our savings account. So it's negative. Our interest rate is 6%. Converting that to a decimal is 0.06. Our number of compounding periods per year, M. It's compounded quarterly, so that's 4. So our periodic rate of interest becomes 0.015. Now to find the number of payment periods, again, NPER. We're looking for our interest rate, okay, which is our periodic rate of interest. Our payment, $200. Present value, we don't know, so we type in 0. Our future value, we do know, so we select that here. Then we do the type. Again, it's at the beginning of the period because it's annuity due. You can double click that and a 1 appears, end bracket. Okay, so that's 23.7 payment periods. I've also included here, if you want to convert that to number of years, well, you have 23.7 payment periods and you're paying quarterly. So your number of years, okay, is simply your number of payment periods divided by your number of compounding periods per year, which is 4. Okay, so that means it would take you 6 years to pay that back. 24 payments, 4 payments a year, 6 years. Okay. All right. So our last example is finding I. Okay, and I've noted it here with present value. Okay. So a loan of $6,000. Again, a loan. You know with a loan that it needs to be present value. A loan of $6,000 is paid off over 5 years by payments at the beginning of each month of $120.23. What is the nominal rate of interest on the loan? Keep in mind we're looking for the nominal rate of interest here. Okay, very important compared to finding the periodic rate of interest. Excel will find the periodic rate of interest, and then you have to remember convert it to the nominal rate. So we know that our loan is our present value, $6,000, and we're making payments, which are negative values, of $120.23. Our number of compounding periods per year, okay, looking back at this question, we're making payments monthly, okay? And in this case, unless I tell you in these questions, you make the assumption, okay, that it's a simple annuity, okay? Because I didn't tell you in here what the nominal rate of interest was compounded, okay? So you make the assumption it's simple. I will typically tell you that though, okay? If I were ever to try and get you to solve this in person. So our number of compounding periods per year is 12 because it's the beginning of each month. Our length of our investment is 5 years, meaning we have 60 payments of $120.23 total. So now to find our interest rate equals rate, okay? And remember here it says the interest rate per period. So that's how you know that it's periodic rate of interest, not nominal. We have our number of periods it's asking for, which is 60. Our payment, $120.23. Our present value, which we know, of $6,000. Our future value, we don't know. Just type in 0. Our type, It's beginning of each month, meaning it's an annuity due. I'll just type in 1. And then our guess, I don't know what the guess is, so I'll just type in 0. Okay? It comes out with our value here of 0.648%. See, I have this set to a percentage. Now, if you want to convert that to a nominal interest rate, well, remember, our compounding periods are monthly. So the nominal rate of interest is simply our periodic rate of interest multiplied by our number of compounding periods per year. Okay? If we do that, you get an interest rate of 7.773%. Okay? All right, so that's it for this lesson. Scrolling back to the top. Remember that you have to make that distinction between annuity due and ordinary annuity using that last piece in the formula where it says type. Okay? If you have any questions, send me a message on Microsoft Teams or send me an email. Thanks, everybody.